Steam turbine receives steam at a pressure of 20 bar, superheated at 300 degrees Celsius. That is, at state 1, the pressure is given as 20 bar and at 300 degrees Celsius. The exhaust pressure is 0.07 bar and the expansion takes place isentropically. Therefore, at point 2, the pressure is given as P2 is equal to 0.07 bar. Using the steam table, calculate the following. We have to find the heat supplied, assuming that the feed pump supplied water to the boiler at 20 bar. Therefore, the feed pump supply water to the boiler at 20 bar, which is nothing but at 0.4, which is P4 is equal to 20 bar. And subdivision B is the heat rejected. We have to find the heat rejected, work done, and thermal efficiency with this given data. That is, we have the value of P1, P2, and P4. The value of P3 is equal to P2 since it is a constant pressure heat rejection process. And 4 to 1 is a constant pressure heat addition process, and 1 to 2 is an expansion process, isentropic expansion process where turbine produces the work, and 3 to 4 is a isentropic compression process where work is given to the feed pump. Okay, and we have to find the value of heat supplied, heat rejected, work done, and efficiency of the Rankine cycle. The properties are being noted from the steam table at pressure 20 bar at 300 degrees Celsius and at 0.07 bar, which is nothing but 7 kilopascal. And I have found out the values of enthalpy and entropy from the steam table. Okay, with this, we have to find the value of heat supplied, heat rejected, work done, and the efficiency of the Rankine cycle. Heat supply is given by the equation Q of S is equal to H1 minus H4. That is, the heat is being supplied from 4 to 1. Therefore, the difference in enthalpy at this two state will be the value of the heat supply. Therefore, Qs is equal to H1 minus H4. From this, you have WP is WP, which is equal to H4 minus H3. That is, the pump work is H4 minus H3. From this, the value of H4 can be calculated. H4 will be equal to WP plus H3. And the heat supplied can be written as H1 minus WP plus H3. The value of H3 is equal to HF2. We know that the value of H3 is equal to HF2. Therefore, the heat supply equation will be as heat supplied Qs is equal to H1 minus WP plus HF2. Now we have to find the value of WP, that is the pump work. And WP is equal to, we know that WP is equal to H4 minus H3, H4 minus H3. And the value of H4 minus H3 can be written as P4 V4 minus P3 V3. The value of V4, that is the volume V4 is equal to V3. That is, you can see from the PV diagram that the volume at 3 and 4 are equal. Therefore, the volume at V3 and V4 are same. Therefore, you can write the equation as WP is equal to V3 into P4 minus P3. And we know that V3 is equal to VF2, and WP can be written as VF2 into P1 minus P2. That is the pressure P4 is equal to P1. From the PV diagram, you can see the pressure P4 is equal to P1 and P3 is equal to P2. Therefore, we can write P4 as P1 and P3 as P2. Therefore, the value of WP is written as VF2 into P1 minus P2. We have the value of VF2 and we have calculated it from the steam table at pressure 0.7 bar as VF2 is equal to 0.001007 meter cube per kg. By substituting this value, you can get Vf2 is equal to 0.001007 into the value of P1 is the pressure at point 1 is 20 bar and pressure at point 2 is 0.07 bar. That is, we can see the pressure P1 and P2 are given as 20 bar and 0.07 bar respectively. By substituting this value in Newton per meter square, you will be getting 20 into 10 to the power of 5 minus 0.07 into 10 to the power of 5. On calculation, you will be getting 2006.951 joules per kg, and the value of WP is being calculated as 2.0069 kilojoule per kg. And now we have find out the value of WP. Now, on substituting the value of WP in the heat supply equation, you can find the value of heat supply. Therefore, QS will be equal to H1 is equal to we have find out the value of H1 from the steam table as 0.3025 kilojoule per kg. On substituting that value here, H1 is equal to 3025 minus the value of WP. We have calculated the value of WP, which is nothing but 2.0069 plus the value of HF2 is being calculated from the steam table as HF2 is equal to 163.4 kilojoule per kg, and you can write as 163.4. By calculation, you can get the value of QS is equal to 2859.79 kilojoule per kg. Now we have find out the value of heat supply. Next, we have to find the heat rejection. The heat rejection, that is Q of R, which is equal to H2 minus H3. That is, from the TS diagram, you can see 2 and 3 process is the heat rejection process. Since the heat is being rejected, it will get a negative sign. Therefore, the value of H3 minus H2 is being rewritten as H2 minus H3. Therefore, the heat rejected is given as H2 minus H3. We know that the value of H3 is equal to HF2. Therefore, you can write H2 minus HF2. We need to find the value of H2. The value of H2 can be found from the equation which states that H2 is equal to HF2 plus X2 into HFG2. We have all the values, that is HF2 and HFG2 from the steam table. That is, we have the value of HF2 and HFG2 from the steam table, but the value of X2 is unknown. This value of X2 can be find out by solving the entropy equation. That is, we know that due to the expansion process, that is isentropic expansion process, S1 is equal to S2. The value of S1 is equal to S2, and which is equal to SF2 plus X2 into SFG2. We have this equation and we know the value of S1, which is 6.77. That is, we have S1 is equal to 6.77 and we have SF2 value and SFG2 value. That is, at 0.074, we have SF2 and SFG2 value. By substituting all these values, you can find the value of X2. That is, by substituting this value, S1 and S2 is nothing but 6.77, which is equal to SF2 is given as 0.559 plus X2 into SFG2 is given as 7.718. From this, the value of X2 is being calculated as 0.8. Now, substituting the value of X2 in this equation, you can find the value of H2. Therefore, by substituting the value of X2 in the enthalpy equation, that is H2 is equal to HF2 plus X2 into HFG2, you can get the value of H2, which is nothing but HF2 is equal to 163.4 plus 0.8 into HFG2 is 2409.2. This value is taken from the steam table. And after calculation, the value of H2 is equal to 2090.6 kilojoule per kg. Now we have find out the value of H2. And if you substitute the value of H2 and H3 in this equation, you can find the heat rejection value. And the heat rejection is given as QR is equal to 2090.6, which is H2, minus H3 is equal to HF2, which is 163.4, and heat rejection is equal to 1927.2 kilojoule per kg. Now we have find out the value of QR, that is the heat rejection. Next we can find the value of work done. Value of work done. The value of W is equal to heat supplied minus heat rejected, and we have the value of QS and QR. By substituting this, you can get the work done value. That is, QS is equal to 2859.7 minus QR is 1927.2. From this, the value of W is being calculated as 932.5 kilojoule per kg. Okay, we have find out the work done. Next, we have to find the thermal efficiency of the Rankine cycle. Thermal efficiency of the Rankine cycle, which is the efficiency is nothing but work done by heat supply, and we have the value of work done as 932.5 and heat supplied as 2859.79 kilojoule per kg. On substituting this value, we can find the efficiency of the Rankine cycle. That is 932.5 divided by heat supplied is 2859.79, which is equal to 0.326. And the thermal efficiency of the Rankine cycle is being calculated as 32.6 percentage. 32.6 percentage.